Alright, so in this problem, I have 9 to the power of x minus 9 to the power of y is equal to 648. So for my solution, I'm going to first start by looking at x and y here. So obviously, by just from looking at it, we can state that x is going to be greater than y, because if x was less than y, then our solution to this equation would be negative, and it's positive, so x is greater than y, meaning that we can say that x is equal to y plus some number k. So now I can replace x with y plus k. So now I have 9 to the power of y plus k minus 9 to the power of y is equal to 648. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of y plus k, that's going to equal 9 to the power of y times 9 to the power of k. I have this minus 9 to the power of y is equal to 648. Now I'm going to factor out 9 to the power of y. So I get 9 to the power of y times 9 to the power of k minus 1 is equal to 648. Now 648, that's the same thing as 81 times 8. And if you notice here, 81, this is a odd number, and 8, this is an even number. So 9 to the power of 9 to the power of y, that's obviously going to be an odd number, right? So we can say that 9 to the power of y is equal to 81, and 9 to the power of k minus 1, that's going to be an even number, because 9 to the power of k is an odd number, and an odd number minus 1 is going to be an even number. So we can say that 9 to the power of k minus 1 is 8. So now this gives me two equations. 9 to the power of y equals 81. 9 to the power of k minus 1 equals 8. So for 9 to the power of y equals 81, y is simply 2. And for 9 to the power of k minus 1, I add 1 on both sides. So I get 9 to the power of k is equal to 9, meaning k is equal to 1. So now that we have the value of y and k, well, remember x is equal to y plus k, meaning x is equal to 2 plus 1. So x is equal to 3. So x is equal to 3, y is equal to 2, and k is equal to 1. Alright, so in this video, I'm going to be proving that 0 divided by 0 is equal to 2. So, for my proof, first start with 0 over 0. Now this is the same thing as 1 minus 1, right? Because 0 is the same thing as 1 minus 1. So I have 1 minus 1 over 1 minus 1, which is 0 over 0. Now this is the same thing as 10 minus 10 over 10 minus 10, right? Because 10 minus 10 is again 0. So I have 0 over 0 still. And this is the same thing as 100 minus 100 over 100 minus 100. Again, 100 minus 100 is 0, 100 minus 100 is 0, so it's 0 over 0 still. Now, 100 is the same thing as 10 squared. So 100 minus 100 over 100 minus 100, I'm going to write this as 10 squared minus 10 squared over, now over here for my bottom, I'm actually not going to write 10 squared minus 10 squared. Instead, I'm going to write 10 times 10 minus 10 times 10, which is, again, allowed. 10 times 10 is the same thing as 10 squared. I'm just not writing it as 10 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b. times a minus b. So in this case, I have 10 squared minus 10 squared. So that's going to equal 10 plus 10 times 10 minus 10. And from the bottom here, from my denominator, I'm going to factor out 10. So I get 10 times 10 minus 10. Now, I'm going to cancel these two out. So I have 10 plus 10 over 10, which is equal to 20 over 10, which is equal to 2. So I just proved that 0 over 0 is equal to 2. So obviously 0 over 0 is not equal to 2, and if you're wondering where the error is in this proof, it's in this step right here, when I canceled out the 10 minus 10 over 10 minus 10. 10 minus 10 is simply 0. So 0 divided by 0, remember, that's not equal to 1. 0 divided by 0, that's indeterminate. So I can't actually cancel these two out because that's simply implying that 0 divided by 0 is 1, which it's not. So this is wrong, and 0 divided by 0 is not 2. Alright, so in this problem, I have 0.2 to the power of x is equal to 2. So for this problem, I want to find the value of x. So for my solution, first start with 0.2 to the power of x is equal to 2. Now I'm going to take the log on both sides. So I have log 0.2 to the power of x is equal to log 2. And if I have something in the form log a to the power of b, I can actually move this exponent b here to the front. So this can equal b times log a. So in this case, I have log 0.2 to the power of x, and I can move x to the front. So now I have x times log 0.2 is equal to log 2. Now if I divide both sides by log 0.2, these two cancel out, and I get x is equal to log 2 over log 0.2. Now, if you notice here, log 0.2, well, that's the same thing as log of 2 over 10. And if I have something in the form log a over b, this is simply equal to log a minus log b. So in this case, a is 2 and b is 10. So I can rewrite this as x is equal to log 2 over log 2 minus log 10. Now, log 10, as we all know, is simply 1. So I have x is equal to log 2 over log 2 minus 1. Now, log 2, this is equal to 0.3010. So I have 0.3010 over 0.3010 minus 1. And now this is equal to 0.3010 over 0.6990. And finally, if I divide these two, I get that x is equal to, this is actually negative 0.6990. X is equal to negative 0.43.